Hello everyone, welcome to another video, another celestial tour. Again, I took a long break, this time mainly for long videos, but the video about Trappist-1 is finally here. So, there are about 55 habitable exoplanets discovered by humans, and I have talked about 10 things that make planet habitable in a video I uploaded when I had like 10 subscribers. And on these planets, life can possibly exist. So that's why I'm planning to make more long videos about life in other places, other planets in planetary systems. And as you recognized, I did a video about Alpha Centauri a year ago, and I'm planning to make more videos about life on other exoplanets since it is something important in astronomy that grabs regular people's attention. So in this video, our topic will be about the Trappist-1 system, which has not 1, not 2, not 3, but 4 habitable exoplanets. Which means there are 4 planets that are in the habitable zone, while our solar system only has Earth, and for example, the Proxima Centauri system only has Proxima Centauri b. So that's the reason why this planetary system is so unique. For more information, without further ado, let's check it out. Located about 40 light-years away from Earth in the constellation of Aquarius, the Trappist-1 star is an ultra-cool M-type red dwarf star. The reason for that is that it has a surface temperature lower than 2,700 degrees Kelvin. The star is 7.6 billion years old, about 3 billion years older than our Sun. Although older, it is only about 8 to 9% of the Sun's mass. In 2016, astronomers monitored our close neighbors using the namesake Transiting Planets and Planetesimals Small Telescope, aka TRAPPIST, in Chile. They look for transits, meaning when a planet passes in front of a star and dims its brightness, making it less visible to Earth. This type of discovery is called the transit method. Low-mass stars are less bright than their sun-like siblings, making it more straightforward for astronomers to detect planets in their orbits, and that's why they discovered the Trappist-1 planetary system with 3 Earth-sized rocky exoplanets, and eventually the other 4 exoplanets were discovered thanks to the Spitzer Space Telescope and other instruments in 2017. These planets are named from B to H and were all relatively the same size as the Earth. The planets from D to G are the habitable planets. Because the star is cooler, smaller, and dimmer than the Sun, the planets would be closer to their parent star than the planets we know in our solar system. I mean, you can roughly fit the entire Trappist-1 system in the space between the Sun and Mercury. The system is that small distance-wise, not only because of its exoplanet sizes. That's why it takes only a few days for all the planets to make one full orbit around their parent star. If you look at Kepler's third law of planetary motion, it states that the closer the planet, the faster it revolves around the star. This can be applied to other planetary systems too. So let's look at these exoplanets, including information collected by the James Webb Space Telescope, starting off with the closest to the star, the Trappist-1b exoplanet. Trappist-1b is the closest exoplanet to the Trappist-1 star. Being a rocky exoplanet, it takes only 1.5 days to orbit its parent star. Can you imagine celebrating the new year almost every day? It is located about 0.011 astronomical units away from its star, with a radius 1.116 times the Earth's and mass 1.374 times the Earth's. This makes the planet classified as a super-Earth because of being more massive than the Earth. Based on the James Webb Space Telescope, this planet's dayside has a temperature of about 225 degrees Celsius. Not as hot as Venus, but since it is not in the habitable zone, it is nowhere near Earth either. JWST also indicated something about Trappist-1b. The planet was thought to have a very dense atmosphere, but interestingly enough, Trappist-1b doesn't have an atmosphere to sustain life, whether it is too thick or fine. So Trappist-1b isn't really on our list because of its temperature and the lack of an atmosphere. Next up is Trappist-1c. This exoplanet also has similar characteristics to Trappist-1b, with the distance from the star being 0.016 astronomical units, taking 2.4 days to orbit around the star, and being a super-Earth. It has a radius of 1.095 times Earth's and a mass of 1.308 times Earth's. James Webb also made another research about Trappist-1c, declaring that Trappist-1c has a very thin atmosphere, that there might actually not be an atmosphere on the planet after all. just like Trappist-1b. So we have absolutely no hope for Trappist-1b and C, but this is where things become interesting. I present you guys the habitable region of the system, starting off with Trappist-1d. Trappist-1d is the lightest planet among all Trappist-1 exoplanets, with a radius of 78.8% of Earth's and a mass of only 38.8% of Earth's, which makes it a terrestrial planet. The planet takes 4 days to make a full orbit and is 0.022 astronomical units away from its star. This planet slips into the habitable zone. We can say the inner edge of the habitable zone because it shows a vital need for a habitable planet, which is water. Although an ice shell like Trappist-1f, G, and H, or a steam atmosphere like Trappist-1b and C cannot be ruled out by scientists, the water of Trappist-1d is most likely in the form of global ocean. Trappist-1d's density suggests that it is primarily composed of rocks, with water making up roughly 5% of its bulk. This planet has a low albedo, meaning more light absorption. Therefore, although this planet is most likely habitable, it has a dense atmosphere and absorbs more sunlight than Earth, and therefore is a little hotter than Earth, with an equilibrium temperature of 9 degrees Celsius. The next habitable exoplanet we have is Trappist-1e. Located 0.029 astronomical units away from its star, it has an orbital period of 6.1 days and it has a radius 92% of Earth's and a mass of 70% of Earth's. Researchers ended up, in conclusion, saying that Trappist-1e was the most Earth-like planet out of all Trappist-1 planets due to its mass, radius, density, gravity, and temperature similar to Earth, making it easy for any civilization living there. Its Earth Similarity Index is 0.95, being the fourth most Earth-like planet, with Earth being number 1, of course. When it comes to temperature, Trappist-1e is actually like Trappist-1d, but the thing that makes it more habitable out of all 7 planets is it receives less sunlight than Trappist-1b, C, and D, and it is less colder than the outer planets, Trappist-1f, G, and H, with having an equilibrium temperature of minus 27.1 degrees Celsius, close to Earth's, which is minus 48 degrees Celsius. NASA has done posters about exoplanets, and here's a cool Trappist-1e poster by NASA to show. After 1e, here comes Trappist-1f. Located 0.038 astronomical units away from its star, it has an orbital period of 9.2 days, has a radius 1.045 times of Earth, and a mass 1.039 times of Earth. Being a super-Earth, it has an equilibrium temperature of minus 54 degrees Celsius, slightly lower than Earth's. Therefore, it is slightly colder than Earth, but the possible presence of liquid water on the exoplanet still doesn't make it an outlier. As you can see, this depiction shows that there is water flowing through the cracks on the surface of Trappist-1f. Similar to Trappist-1f, we now have Trappist-1g. Located 0.047 astronomical units away from its star, Trappist-1g has an orbital period of 12.4 days, a radius 1.129 times Earth's, and a mass 1.321 times Earth's. Also being a super-Earth, Trappist-1g marks the outer limit of the habitable zone. It is colder than Trappist-1f with an equilibrium temperature of minus 75 degrees Celsius. As you can see, just like Trappist-1f's depiction, the cracks on this ice planet. And lastly, we have Trappist-1h. Located 0.062 astronomical units away from its star, Trappist-1h is the furthest planet from the Trappist-1 star. With an orbital period of 18.8 days, a mass of 32.6% of Earth's, and a radius of 75.5% of Earth's, Trappist-1h is a cold ice dwarf due to its distance from its star. Although it isn't really the habitable zone, even Trappist-1h harbors water in it, but it is again most likely in the form of a thick ice crust. Some scientists say that Trappist-1h might have liquid water, but it doesn't really have a thick atmosphere which helps develop liquid water. However, an underground ocean might possibly exist on this planet, which can be linked to the volcanic activity of Trappist-1h. Finally, I would like to note that most of these exoplanets are tidally locked, meaning that one side of the planet faces the star and the other side is in total darkness. So this can possibly affect the data coming from the exoplanets. So, in conclusion, the Trappist-1 system impresses astronomers a lot because the Trappist-1 system is very unique, whether it is about having 4 habitable exoplanets, the heavy involvement of water on these planets, or having very short orbital periods. Who knows, maybe extraterrestrial life on, say, Trappist-1e is existing. I hope you guys learned some valuable information about the Trappist-1 system and its exoplanets, and as always, thank you for watching. Stay astronomical.